So we're working with inverse trig functions and solving right triangles. So imagine that you're on a tropical vacation and you're getting ready to zip line down a zip line, and the operator of the zip line says, hey, you need to make sure that you're in torpedo mode for the first 3 yellow balls of this particular zip line. So you think, what in the heck is torpedo mode? Well, in torpedo mode, you are making yourself as streamlined as possible so that you can get down that zip line as fast as possible. Well, wait a minute, maybe I want to enjoy this and enjoy this for as much time as possible. Well, as you're ziplining, as you're torpedoing down, you're supposed to go until the 3rd yellow ball, and then you can relax and sit up and enjoy the rest of the ride. Well, what happens if you don't torpedo? Well, just before you get to this platform, this can happen. So you have to be a certain weight and you have to torpedo in order to be able to get all the way to the platform. Well, why is that? Well, in Labadee, Haiti, there's a zip line that goes across water, and it's 2,600 feet long. It starts 500 feet above the beach, and so neglecting the sag of the line, we're going to figure out what is the angle of depression of this line in order to see why it's important to torpedo mode on the way down the zip line. So first of all, we've been working with trig ratios. We've been working with the sine, cosine, or tangent of an angle. So for example, if we know that we have a 30-degree angle, the sine of that 30 degrees when we pop it into our calculator gives us 0.5. That means that the opposite divided by the hypotenuse is going to be 0.5. The short leg over the hypotenuse, since the hypotenuse is double the short leg, is going to get you 1/2. Well, just like the calculator has those ratios, those angles stored, it allows you to do the reverse as well. So in this case, it's going to tell us how to get the angle back when the opposite side divided by the hypotenuse is going to be 500 feet divided by 2,600 feet, or 5 divided by 26 if we simplify. So going back to our original problem, it said, hey, let's find the angle of depression. What kind of angle are we going down at from that top peak of the zip line platform? And so, because parallel lines cut by a transversal have alternate interior angles that are equal, this angle of depression is going to be the same as this angle of elevation. So in this right triangle, we're trying to figure out what the angle is this time. We don't know how many degrees this measures. So when we look at our good old SOHCAHTOA, we're looking for the opposite over the hypotenuse ratio to figure out what the angle is. Which of the 3, sine, cosine, or tangent, works with opposite and hypotenuse? Absolutely, it's the sine. So let's set up our trig ratio here and say the sine of x degrees this time is going to be equal to, because the angle is always with the sine, cosine, or tangent, and this time we don't know what it is, but the sine of x degrees will be equal to the opposite divided by the hypotenuse. And so we have to make sure that when we get out our calculator, once again, it's in degree mode because we want our answer to be in degrees. And we're going to be working with the sine, cosine, and tangent buttons again, but this time there's a slight twist to it. If you notice, there is a sine, looks like to the -1 power, cosine -1 power, tangent -1 power, right above the sine, cosine, and tangent buttons. That's not a -1 power. That's what's called the inverse sine, inverse cosine, and inverse tangent, also known as the arc sine, arc cosine, and arc tangent. And what it does for us is it tells us what angle has this ratio for its opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent, as the case may be. So we're going to be using the second or the shift button on your calculator in order to get to that font, that text, that option that's above the sine, cosine, or tangent. And so we are going to press our second button on our calculator, or our shift, and then we type in sine, the inverse sine, the arc sine of 500 divided by 2,600. And we can close our parentheses if we want to, or we can leave it as it is. And when we press enter, we should get an angle measure that makes sense for our drawing, especially if the drawing is drawn to scale. Does it look like this could be an 11.0874 and some change degree angle? Absolutely. So our answer is going to be 11.1 if we're using one decimal place, rounding to the tenths place, 11.1 degrees, or 11 1/10 degrees. Some calculators go backwards. So if you have that calculator where you had to type in 30 and then sine in order to get our angle of our measure of 0.5, our ratio of 0.5, then you will need to go backwards on your calculator. And that means that you're going to type 500 divided by 2,600 first, press enter so that you have that decimal, that ratio, and then you're going to do a second sine. So practice with your calculator to make sure that you get the right answer. This one should be 11.1 degrees. And the next screen is going to allow us to practice some more. So I want you to find out what angle has an opposite over an adjacent of 3.29. Did you get 73.1 degrees? If so, good job. If not, try again. Make sure your calculator's in degree mode. And if your calculator needs you to go backwards, you would type 3.29 second or shift tangent. And then you should get 73.1 degrees. Try the sine of b is equal to 55 hundredths. So we want to get the b by itself, and there's a sine in the way. The way to do that is to do an inverse sine of a sine of angle b, and just like when we square root as x squared, these two negate each other. They're inverses of each other. They counteract each other. The same thing happens here. Inverse sine of the sine of b is the same thing as the inverse sine of 55 hundredths. So second sine, 0.55. Did you get 33.4 degrees? Hope so. Next one, we want to get to the angle C, so we're doing an inverse cosine of a cosine of C, and that means we are going to press the second or shift of cosine and then 0.87. Did you get 29.5? Good job. All right, so now we're ready to find the measure of an angle. And in the past, we've always given you an angle, asked you to find a side or the hypotenuse, and here we are asking you for the angle itself. So here's our angle, angle A. Think about standing at angle A. If you put yourself in this drawing and this was your foot and here's your other foot, where is the 3 in relationship to where you're standing? Well, it's across from the triangle from you, so it is far away from you. This is the opposite side. And because you could step on this line and it's not the hypotenuse, here's the hypotenuse, the longest side of the triangle, opposite the right angle, then the side that you could step on with your foot is the adjacent. So the two pieces we know are the opposite and the adjacent. Do you remember how to spell SOHCAHTOA? Which of the sine, cosine, and tangent works with opposite and adjacent? That's right, it's the tangent. So the tangent of our angle always goes with sine, cosine, or tangent. This time we don't know what it is, so we're going to call it angle A. That means that we're looking for the opposite divided by the adjacent, 3/5. And now we break out our good old calculator because we want to get to the A, and to get rid of a tangent, the inverse tangent of the tangent of A will give us a plain old A. And the inverse tangent, we do the same thing to both sides of the equation, same operation, is going to say, hey, I need you to press second tan or shift tan, and then 3 divided by 5 on your calculator. When you do that, did you get 30.96? Or now if we're rounding to the 10th place, the 6 makes the 9 a 10, and so did you get 31.0 degrees? Excellent. Next one. We're again finding the measure of angle A, but this time we have the hypotenuse, the longest side of the triangle, the side opposite from that 90-degree angle. And if I'm standing here at angle A, we don't know anything at all about the opposite side. It's far across from the triangle, does not touch angle A, does not make that angle, but the side that we could step on, the adjacent, is the 24. And so, adjacent hypotenuse, which of our trig ratios works with adjacent and hypotenuse? That's right, it's cosine. Cosine is the adjacent over the hypotenuse, so the cosine of angle A, angle always goes with sine or cosine or tangent, cosine of angle A is the adjacent divided by the hypotenuse. So you have to set these up. Can't just have answers. Write your ratios out, write your equations out. And then use your inverse cosine of 24 divided by 25, shift cosine, arc cosine, the second cosine, depending on your calculator buttons. Did you get 26.3 degrees? Sorry, excuse me, 16.3 degrees? Does that look like it's a reasonable angle for that particular angle if it's drawn to scale? You bet. All right, last idea here. We want to be able to solve the right triangle. Solving the right triangle means you're telling me everything there is to know about this triangle. I want to know what is the measure of angle L, the measure of angle K, and we know the measure of angle J was 40 degrees. We know the measure of angle L is 90 degrees because it has a right angle there. 180 degrees for the sum of the interior angles of a triangle minus the 90 that's used up by angle L gives us 90 left. 90 minus the 40 that was angle J tells us that we have a 50-degree angle for angle K. So don't lose those easy points. Those are the easy ones. You've been doing that forever now. So now we need to find also the sides. When we're working with the right triangle, we like to label the side that's opposite angle K a lowercase k. The side that's opposite angle L a lowercase l. And the side that's opposite angle J a lowercase j. Makes things simpler. It's easy. That's our common notation for that. So we're going to find out what is the measure of angle L, the distance between points J and K. We're going to find out what K is, side K, what it has for its measure, and we know that side J is 6. So to do that, let's find the hypotenuse first. The hypotenuse is side L, and the angle that we know is angle J. So this is our reference point. This is where if we're standing or putting ourselves in this triangle, we're putting our feet right here. So the 6 is opposite the triangle from angle L. And the hypotenuse is side L, so I could step on side K, that's the adjacent. So if we're trying to find the hypotenuse first, and we know the opposite is 6, and we know the angle, opposite hypotenuse, we're working with the SO part of SOHCAHTOA. So the sine of the angle, 40 degrees, angle always goes with sine, cosine, or tangent, is equal to the opposite divided by the hypotenuse. I'm going to make this a curvy L, or a script L, so it doesn't look like a 1. I need to solve for L, and 6 is being divided by L. So if I multiply both sides by L, or think of this as being sine of 40 over 1, so I can do a cross product here, then L times the sine of 40 equals 6. Those two cancel. I need to get the L by itself. That means I need to divide by the sine of 40. So L will be equal to 6 divided by the sine of 40. Again, you have to show work here. You can't just have answers, because you need to set up the equations and solve them, and then let the calculator do the work. So when you typed 6 divided by the sine of 40, did you get 9.3? If so, great job. That's the hypotenuse. It's longer than the 6. That makes sense. It actually looks like it's about, if we broke this into half, into threes, it looks like it's a little bit more than 3 of these lengths, so we're good. So now we need to find the side K, the adjacent to angle 40. So it's always good practice to try to use the things that were given to you in case we made a mistake. If we made a mistake finding out what L is and now we use L, we can perpetuate that, snowball it, and actually make another mistake. So once we realize that we are looking for the adjacent and we have the opposite, then we want to use the tangent of 40 degrees. Angle always goes with sine, cosine, or tangent. That's equal to the opposite divided by the adjacent. Again, use a cursive L so you don't confuse yourself and make it you think it's the 1. Now we're ready. We have our equation set up. Let's solve it. If we cross multiply, L times the tangent of 40 degrees is equal to 6 times 1. We need to get the L all by itself, and it's being multiplied by the tangent of 40. The inverse operation for multiplication is division, so we divide both sides by the tangent of 40. And L will be whatever 6 divided by the tangent of 40 is. Sorry, been writing L and not K. My apologies. We're trying to find the adjacent. Stuck on L for some reason. And so K will be equal to 6 divided by the tangent of 40. And did you get 7.2 degrees? Sorry, 7.2 for his length. Awesome. K is equal to 7.2. As I say 2 and write 1. All right. Hopefully that helps you be ready. Make sure you set up your ratios, set up your equations, then solve them. Thank you for watching. If you want to explore more, you can ask yourself, is the zip line in Labadee, Haiti actually 2,600 feet long? And if so, is the vertical drop also really 500 feet? Google Earth it. Check it out. And if they are not as publicized, find out what would be the angle of depression.